All right. So from where we were yesterday, I want you guys to take a minute or two and try these two examples. This is what we did yesterday. If you can do this, you are good to go with what we did yesterday. So what I want you guys to do is write an equation with the given point, with the given slope, and then write an equation of a line through the 2 points. So literally take about 2 minutes and get this done, and then we're going to move on. One more minute. Okay, so on number one, and again, notice I did not give you any equations. You're going to have to know those equations. So the two equations that we use are slope-intercept form and point-slope form. So point-slope is y minus y1 equals m times the quantity of x minus x1. So I can plug into the y1, the m, and the x1. By the way, I know a lot of teachers might have had somebody that taught them just slope-intercept form and plug in for the y, the m, and the x. I do not care how you do this at all. So there's a bunch of different ways that you guys could do this. I just want you guys to get the final answer and make sure you know how you got it. So if I chose point slope form, that's my x1 and my y1, plug and chug. So y minus 2 equals my slope, which is negative 1/2, times the quantity of x plus 3. Now, that's an equation. If it's set in slope-intercept form, I would have to distribute. Now, the reason people are going to struggle with this is just because it's a fraction. Do not let fractions throw you off. Negative 1/2 x. If I ever have a fraction times a whole number, all I have to do is multiply by the top. So that's negative 1 times 3, which is negative 3 divided by 2. Now, the next part is if I add 2 to both sides, I just have to get a common denominator. Well, 2 is really 4 over 2. So this is really adding 4 over 2. So my entire answer here is y equals negative 1/2 x plus 1/2. Now I'm going to show this to you guys one time, and then I do not care how you do this. If I give you a point and a slope, use point slope form. However, you don't have to. By any means, you do not have to. I could use slope intercept form. And again, I'm not trying to confuse anybody, but here's another way to do this. If I know that that is slope intercept form, and I know that this is an x and a y, and I already know my slope, well, all I really have to do is find b. So my y value is 2, my m is negative 1/2, my x is negative 3, plus my b value. Negative 3 times negative 1 is positive 3/2. So then I just subtract 3/2 from both sides. So 2 minus 3/2, so that's 4/2 minus 3/2, and I find that my b is 1/2, and then I plug it back in. So my m is still negative 1/2, that gets the x, plus 1/2. Any questions? Again, you can choose either method. I'm not one of those teachers that say you have to do things my way. I realize that there's a lot of different ways that are all perfectly fine to solve these. So, number 2, you have to start by finding your slope. My slope is going to be y2 minus y1, or -2 minus 2 over 3 minus -1, which is 3 plus 1. So I've got -4 over 4. So my slope is -1. Choose a point, whichever point you want. It doesn't matter. I'm going to go ahead and choose the first one because the numbers are closer to 0. And then I'm going to use point slope form. So y minus 2 equals -1 times the quantity of x plus 1. Distribute, and here's what you've got. Add 2 to both sides. And that's your entire answer. Any questions? And that's a -1x plus 1. No. All right. So those 2 problems are what you absolutely have to know going into this. Again, I know you guys did that a ton in Algebra 1. You probably didn't do it very much last year. So let's go ahead and let's look at some story problems. So now that we know how to do it, now we're actually going to do some real life type problems. So you know that a shirt company charges a setup fee and a certain price for each shirt. You know for 10 shirts, the cost is $25 and the cost for 25 shirts is $55. Well, I want to know the breakdown. We could do this a couple different ways. And again, I don't care how you guys do this, how you think of it. But I know it is usually a cost per shirt, which means the cost depends on the number of shirts. So that means shirts are going to be my X and the cost is going to be my Y. All you really have to do is to write the ordered pairs and do the same thing. So for instance, my first point, I know that 10 shirts cost me $25. I know that 25 shirts only cost me $55. Now, here's the thing. You do this exactly like we did problem 2 on that first page. Exactly like that. Your slope is your price per shirt and your y-intercept. So your y-intercept is always going to be that initial fee, that initial price, the original cost. So your setup fee in this case is your y-intercept and your price per shirt is the slope. So take a minute and try and find the equation here. All right. So I only see about 7 faces anyway, but I see some people look like they're starting to get this done. I want to give you guys as much opportunity as possible to start your work with me on here. So again, to find your slope, I'm going to do 55 minus 25 over 25 minus 10. Again, y2 minus y1 over x2 minus x1. So 55 minus 25 is 30 over 15. So I know that my slope is $2. So putting it back in context, that's changing. So my price is $2 per shirt. Now, I want to see your work. I want to see your thought process, how you guys are doing this, because there's more than one way to do this. I could simply look up here and say, well, wait a minute. If my cost per shirt is $2, and I know for 10 shirts, it costs $25, well, those 10 shirts themselves would only cost $20. So that means the setup fee has to be $5. And then check it with the next one. My slope or my change, it's $2 per shirt. So 25 times $2 is 50. So again, my setup fee is $5. I do not care how you do it as long as you show me your, especially when we get back in person, as long as you guys show me your thought process. Or you could just write the equation. So I've got y minus 25 equals 2 times the quantity of x minus 10, distribute, add 25. So we're doing the exact same math. We're just putting a situation or some context with it. That's the equation. So what's my setup fee? My setup fee was my initial charge, which is $5, plus they're charging $2 per shirt. So make sure that you guys answer the question. Now, any questions on that? No? Okay. So if we went back to the beginning, the title of these notes are modeling linear equations. This is kind of what it looks like. So we're only going to do 2 or 3 examples. Now, I want you guys to understand how to do line of best fit. On Monday, I do want you guys to bring your calculator, and by bring your calculators, have your calculators next to you. Now, as a department, there's serious concern about a lot of people still not having a calculator, and I get that. So we're kind of pushing that lesson back as long as possible, but I'm still going to show you how to do a lot of this stuff on your calculator. For today, we're doing this all by hand. So here's the thing. Read the question. You're going to have a lot of information up here. The graph shows the distance that this asteroid travels in x seconds. So x is your seconds, x is your time, y is your distance. I can go ahead and write that right away. X is your time, y is your distance. It wants you to write an equation of the line and interpret the slope. Now, the asteroid came within 17,200 miles of the Earth. About how long does it take the asteroid to travel that distance? Well, I have to find my slope first, right? So if in 5 seconds it traveled 24 miles, yeah, that's pretty fast. In 5 seconds, it traveled 24 miles. Find the slope. Well, for part of this, all you have to do is find another point where it hits a square corner or find your y-intercept. In this case, I know that my second point is 0, 0. Let me change colors here. So my second point is 0, 0, which means after 0 seconds, it has traveled 0 miles. Now, if it starts at the origin, this is real simple. I can just do a rise over run. So rise over run, it went up 24, 24 minus 0 over 5 minus 0, and over 5. So my slope is 24, and I can go ahead and put the label here, 24 miles every 5 seconds. Now, question, because I don't want to just sit here and do this with you. If the asteroid came within 17,200 miles of Earth, how long does it take for the asteroid to travel that distance? I'm going to give you guys probably more time than you need. I'm going to give you about 2 minutes to think about how in the world can I answer that question. All right. So go ahead and go. I'm going to put this on you guys to do this for just a second. All right. So I don't want you guys just sitting there. I know that some of you guys are working and some people are probably just waiting for me to give them the answer, but I'm not just going to give it to you. So somebody tell me, what's your thought process? How do you think that you can find this? Does anybody have any idea how you can set this up? So if it's traveling 24 miles every 5 seconds, well, how long did it take? How long does it take to travel 17,200 seconds? Or 200 miles, sorry. Anybody have any idea? Man, yeah, go ahead.
What I did, or at least what I think I'm
Mhm.
supposed to do, I divided the 17,200 by 24. Oh,
Okay.
never mind. That's not right.
Now, hold on. It's not entirely wrong either. So let's go back up here. And again, I know some people are thinking, wait a minute, this looks completely different. Well, it is. The whole equations part and the slope came from this and putting it in context. So all this means is it is traveling 24 miles every 5 seconds. So think about that. We can set up a proportion. So the proportion, and again, I've got 24 miles every 5 seconds, and I want to know how long is it going to take for it to go 17,200 miles. So it's going to travel that in this many seconds, right? So one of the things you're going to have to do in this class is connect it to what you've already learned. And that's kind of what I'm showing you here with example one. I didn't just expect you to know that, but I want you guys to kind of think through the problem and how can you solve it. And how do you solve any proportion? By simply cross multiplying. So what you said wasn't wrong. Equals 17,200 times 5. So if we multiply that out and then we solve for x, divide by 24, that will give us the right answer. Again, there's multiple ways to do this. But to me, this makes the most sense. So we already have a ratio of our miles per second. So this many miles per this many seconds. So 17,200 times 5, which gives us 86,000. and then divide both sides by 24, and we end up with something like this. And then what did it do? It traveled 17,200 miles in 3,583.33 seconds. So make sure you guys put the label. Again, as we're getting into real life math, make sure that you answer the question. So 3,583.33 doesn't really answer the question. You have to put the label to it. All right. Again, there's more than one way to do this, but that's how I chose to solve it. Let's move on to the next. Now, we're only doing 3 examples today, but this is a big one. So I have seen this on iStep, which is now gone. They're replacing it with something else. And I've seen something like this on the ACT where you're just comparing an equation with some data. So you guys completely know how to do this. You just haven't done this exact problem. So I'm going to read you through this. So 2 prom venues charge a rental fee plus a fee per student. So a flat fee for the rental fee and then a fee per student. The table shows the total cost for different numbers of students. That's at Lakeside Inn. The total cost Y in dollars for X students at Sunview Resort, this is Sunview, is represented by this equation. So Lakeside gave us a table. Sunview, so Sunview gave us an equation. Wants to know which venue charges less per student, and then how many students must attend for the total cost to be the same. Now, this is really setting us up for what we're doing a lot of next week. Well, let's go through here real quick. The total cost in dollars for X students. So my cost is $10 per student plus 600. So back to this, my slope is the cost per student, and the 600 is the initial fee. So everything we know about Sunview is it is $10 per student and my initial cost is $600, or my y-intercept. Again, if we were in class, this would be extremely interactive. A lot of that gets lost here. Now, this is what we were just doing. And some people are going to say or think, wait a minute, now we've got a table. We were dealing with points. I do not care as long as this is linear, which means it goes in a straight line. They don't give you a discount after so many students, whatever. So all we have to do is find the slope. You can pick any 2 points you want. I can pick this point and find the slope. Or I could pick this one to this one and find the slope. Or this one to this one. Hopefully you guys are following. So with that said, if I am trying to find the slope, it is difference of y's over difference of x's. So we're really starting to get into this, and this is more of that Algebra 2 piece. Even though you did it in Algebra 1, I expect that after 1 or 2 examples, you'll get this. So this column is my y's, this is my x's. So difference of the y's, so 1,800 minus 1,500, over 125 minus 100. So my slope is going to be 300 over 25. So my slope is 12. Again, what does that mean? That is my cost per student. So Lakeside is going to be $12 per student. Well, before I answer the questions, let's go ahead and find, well, if it's $12 per student, then how in the world do I find what my initial cost is? Again, you can pick any one of these points. Pick the one that you think is the easiest to use. Guess what? I like this one. So I can either use common sense here. If it's $12 per student and I have 100 students, that's $1,200. My total cost was $1,500. So that means my initial cost has to be $300. If you don't want to think, first of all, start wanting to think. It'll save you some work. Set it up in point slope form. So y minus 1,500 equals your slope, x minus 100. So again, it's the exact same skills that we worked on yesterday, now with just some context. Distribute it. Add 1,500, and Lakeview is going to be this. Now, if we were in person on the test, you actually would have two exactly like this on the test. While we're not going to have the test, I'm still going to give it to you because you are responsible and you need to be held accountable for what we've been doing. So you need to learn this. If and when we come back in person, we're not going to spend a lot of time on something like this, but it is on the final. So let's answer the questions now. Back up here, Sunview cost $10 per student and had a $600 rental fee. Lakeside is $12 per student and had a $300 initial rental fee. So if I don't have very many students, I should go to Lakeside if I'm trying to keep the cost down. If I have a ton of students, then I want to pay less per student and I don't mind paying a higher initial cost. But which venue charges less per student? It is Sunview. Now here's the question. Next week, we're going to get into systems of equations. And this is the start of that. So I've got my two equations now. So the question is this: how many students must attend for the cost to be the same? I want the cost of this to equal the cost of this. So how can I do that? All I really have to do is set them equal to each other. So I want Sunview to be the same cost as Lakeside. And then solve for x. Now I set it up as an equation here. I easily could have set this up as a system of equations, but that's what we're going to get into. Solve for x. Subtract 300. So again, don't leave it as x equals 150. Make sure you answer the question. So how many students must attend for the cost to be the same? 150 students. Now I could say, what would that cost be? Well, I could either look at this table and say, well, the cost for it to be the same, it would be 2,100. But make sure that your answer makes sense. So 150, if I plug in 150 back up here, so 150 times 10 is 1,500 plus 600 is 2,100. The costs are in fact the same. Any questions? Okay. You're not going to like example 3. It's very difficult to do here. But this is what we're going to start with. I'm going to do this one time by hand. We'll talk more about line of best fit on Monday. We'll do it one time by hand. And then on Monday, I'll kind of show you how to do this on the calculator. So always read this. The table shows the femur lengths and heights of several people. Does it show a linear relationship? Basically, by a linear relationship, what I would expect is that the longer the femur, the taller or the bigger somebody is. Now it says right here, your femur length is X, your height is Y. We know that this is the X axis and this is the Y axis. Again, here's something else. I drew this by hand, so these tick marks might not be exactly even. But my X are going to be femur length. And my Y is going to be height. Again, this is one of the skills that you need to have. Now, I want to show you guys something. Before you do anything else, after you've labeled your axes, go through and I want you to just look at these. It looks like my smallest one here is 32. And it looks like my biggest one is 50. So if I'm trying to represent that up here, I can draw in like a broken graph. Now what that looks like when you get in the book, it'll be here, straight line, and then it will literally have some squiggles like this, which just shows that the graph has been broken. So we're cutting that out. All right, so if I know that my shortest is 30 and my longest is 50, I can do something like this. I can go ahead and do 30. And just because this is kind of messed up, then I'll go by, let's go by 4. So 34, this would be 38. This would be 42. That's 48. That's 52. Maybe I should have just, let's go back and let's go by 2s. Sorry. I don't want it to be too close together. So 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50. And we need to say this is in centimeters. All right, same thing with the height in centimeters. I find my smallest one, which looks like it's 141. And my biggest one is 195. So 141 to 195. So I'll start with 140 and I'll go up by 5s. So 145, 150, 155, 160, 165, 170, 175, 180, 185, 190, 195. Okay. Now you guys do have some free reign. Somebody might say, well, I went by 5s everywhere. That's fine, but you want to kind of match these up to fit your data. If I make this down here too big, for instance, if I went by 10s, 30, 40, 50, then all of my data would be like right in here, and it's very hard to tell. And we'll talk about that a little bit more later, but now we're going to plot the points. So when my femur length is 40, my height is 170. So 40 to 170 looks like it's going to be about right here. 45 and 183. 45 and 183, again, is about right here. Doesn't have to be perfect. So 32, 151, 32, 151, 50, 195. Well, I can kind of tell right away. I've only graphed 4 points, and it says, does the data show a linear relationship? Well, it does. It looks like it's going up in a straight line. Let's keep going. So 37, 162, 37, 162. 41, 174. 30, 141. 34, 151. 47, 185. And then 45, 182, which we pretty much already got. All right. Now we'll talk more about this later. Your line of best fit. Needs to try and go through at least 2 points. But one thing, I want to have about the same amount of dots above it and below it, which means if I'm trying to do a line of best fit, I don't want to come down here and I don't want them all to be above it. That's not a good line of best fit. I don't want to just go through a couple of the first two. That's not a good line of best fit. So instead, I want to try and find the pattern, and I want about as many to be above it as below it. Now that's a pretty good, maybe not perfect, but that's a pretty good line of best fit. Perhaps a better one, start a little lower, would be something like that. So this is the last example, and then you guys, I'll show you your homework. You've got like 10 questions tonight. But does it show a linear relationship? Yes, because these dots, these points are clustered to where it looks like it's going in a straight line. We can make a fairly accurate prediction of somebody anywhere within this data. For instance, if I said, I want to know somebody with a femur length of 46, how tall would we expect? Well, I'd come straight up to 46. And I'd say, oh, it looks like they are about, I'd say 185 centimeters tall. All right. The last thing is write the equation. I'm not going to finish answering this question with writing the equation, but I want you to see how. Once you have this, pick any 2 points that it looks like it goes through. So it looks like it goes through this one, which is, let's see, 45, 183. And where else does it look like it goes through? Looks like it goes through 30, 141. And once you pick those 2 points, you do the exact same thing. Find your slope and write the equation. On Monday, I'm going to show you how to do that on your calculator. So, and you need a graphing calculator to do that. I realize we've only got about 3 minutes left in tonight's assignment, or in today's class. So this is all for tomorrow. Oh, sorry. This is all for tomorrow. I say tomorrow, Monday. Your assignment's on big ideas. It says 3 through 10. You've got 10 questions. In the old school book, it's 3 through 12. Does anybody have any questions at all? Okay, so then before we leave, I'm sorry, these glasses, they're actually blue light glasses. They're supposed to help with headaches from looking at the screen. I'll let you know how it works. I know I look super nerdy right now. Anybody have any questions? All right, then you guys have a wonderful weekend. What type of calculator do we need? Look into a TI, Texas Instrument TI-84. So a TI-84 is what I will be teaching with. And that's what I'll be showing. If you get a Casio, it works just fine. It's cheaper, but it keys differently, and I can't help you with a lot of that stuff, okay? So try and get a Texas Instrument if you don't have one already. All right, everybody else, I'm going to stop recording. Have a